So I'm here again with Katharina. Hi. So I'm wondering now, what are the trends and challenges that are most pressing in the semiconductor industry?
So I think one challenge is really to be always on the innovation forefront. So the challenge always keeping up with Moore's law, basically every second year to double the transistors on a chip. So you have certain limitations by physics that's just not going that way on a horizontal layer. So you need to vertical get it up, and then this is kind of the new trend of chiplets where you actually stack the topics basically from a vertical perspective, not just only horizontally. I think that's one main driver with regards to innovation. Then, of course, the topic of sustainability. So it's an industry we talk trillions. So we have a trillion liters of water which is being used in the semiconductor industry. We have 100 million tons CO2 equivalent emissions. So we talk really high numbers, actually, if we look to the sustainability front. And that's something which we need to solve jointly. And then also the topic of cybersecurity, for example. We take the topic of Taiwan. They face several thousand attacks a second. So this is really huge because IP needs to be protected for all the companies. So we get several reach outs also on the topic of cybersecurity. And then, of course, the whole trend of smart manufacturing, digitalization of the factory, really not only on the automation front, but also the backbone of the fabs, digitalizing that and renewing the systems where basically the machines are running from, that you can also apply new technologies like AI and that things are communicating with each other.
You already touched a little bit on the topic of technology, so I'm wondering what technologies are especially important to speed up profitable and sustainable growth in the semiconductor industry.
Yeah, for me, really key is the digital twin. Having really a simulation of your fab, for example, a greenfield fab. So Siemens is using that technology also to build factories completely digital native and to transfer that also to the semiconductor industry to plan a greenfield fab fully digital, but also using the digital twin for example, a facility monitoring control system to really make a digital twin on an operational level, brownfield, simulate and improve continuously the processes and validate also what's working, what's not working. That's for me really key and brings the industry also to the next level.
You mentioned fab before, and I have heard that we're also showing that right here. So if we have a look up, what can we see at the very top of this exhibit?
That's a facility monitoring control system, and many people don't know that Siemens is actually active in the space because you don't see it if you enter a fab. It's all in the background or even the sub-fab. So we are actually automating the flows of energy, gas, water, that everything is actually reaching the right level. And you need to understand the clean room, the kind of conditions you have there need to be very stable on humidity, on temperature, cleanliness. You can't wear any makeup being in the clean room because every single particle will just destroy the chip production. So it's so sensitive. Makeup, also deodorant, is not possible. So I think things like that, many people don't know, and we are actually enabling the clean room working at the best conditions, and it's all fully redundant because obviously it cannot stop for 1 second or a minute because that will already destroy basically the wafers which are right now in the production line.
I definitely did not know that it's so sensitive. So how are we at Siemens really supporting in all of that? You mentioned sustainability. It's really an important topic to do something about that. So what concretely do we offer at Siemens?
So we offer basically the whole automation, which is doing that flow, but we also go even deeper, for example, in the gas cabinets, and we have that also right here with our hardware, automation of the gas flow. So what gas is actually flowing, how can we control that not too much gas is flowing, not too much energy is going somewhere, and also using there the digital twin and simulation to optimize further, to optimize on energy management, for example, and that has direct impact also on the sustainability KPIs and criteria.